Hello students, hope you all are doing well. Here in this video, we are going to present you another chemical industry. For this time, we are going to talk about the extraction of magnesium. It's magnesium extraction industry. That's what we are going to find it out here. Students, magnesium is the lightest structural metal used today. It's 30% lighter than of aluminium. It's widely used in manufacturing of those alloys. But this pure magnesium burns vigorously once when it exceeds its melting point, which is 650 degrees of centigrade. These alloys of magnesium are having very high melting points. Those are used in automotive as well as aircraft industry. Students, magnesium is the third mostly used in manufacturing metal currently. It's after iron, aluminium, you could find magnesium being used as the third most construction metal. So when you check for the uses of magnesium, out of those total production of magnesium, it's nearly 70% of magnesium could be found out being used in manufacturing of alloys. It's for the features of which those alloys are very low densities, relatively high strength as well as excellent machinability. We use those alloys. It's one or more of those elements, aluminium, zinc, manganese and silicon could be found being mixed with those alloys with magnesium. Students, when you find it out, half of those alloys could be found out as die-casting with 90% of magnesium. What are die-casting? Die-castings are that liquid alloy mixture would be injected inside those molds or templates. They are manufacturing those alloys are called die casting. With high pressures, we inject those inside molds. Then students, you will find those being used to manufacture those components in automobiles, like the gearbox casings as well as steering wheel core. Then is the structure of the dashboard. Then radiator supports. Then further you could mix some other rare metals like zirconium and some other such to strengthen those alloys further. Then those are manufactured as sand cast alloys. Then students, such group of metals, alloys could be found being used in manufacturing the gearbox of helicopters and its jet engine auxiliary gearbox as well as high performance vehicles. Then it's the casing of those cameras. Then students, the other half of those alloys are used as in their magnesium is used as the alloy additives of mostly in aluminium. Magnesium is mixed with aluminium alloys there. Students, it's those food packagings like beverage cans, drinking cans, as well as those foils are manufactured with such alloys. In United States, they manufacture those beverage cans with aluminium alloys with 5% of magnesium content. Then in Europe and Asia, those beverage cans widely manufactured with 50% of steel as well as 50% of aluminium alloys. There you would find magnesium being used as the alloying additives. Magnesium alloys also serves as sacrificial anodes. When connected with low reactive metals, magnesium alloy become the anode of an electrochemical cell, making that metal, low reactive metal, into the cathode of the cell. So it protects that low reactive metal from corrosion. This kind of protection is referred as the cathodic protection. Such protections are applied by magnesium alloys. They are in hulls of steel ships, underwater structures of oil platforms, as well as water pipelines. From corrosion, it protects those magnesium alloys. Then students, it's another 10% of manufactured or extracted magnesium could be found out using their in extraction of titanium. It's another application. Extraction of titanium from titanium dioxide. Then students, it's another 10% around could be found out using manufacturing high grade steel. Magnesium there is used to manufacture high grade steel. High grade steel is used in heavy constructions like manufacturing those bridges as well as buildings and such. Then those high grade steel could be found out being manufactured using magnesium, as those molten iron would be treated with molten magnesium. Iron consists of some impurities like sulfur. So sulfur there would react with magnesium, forming magnesium sulfide. This magnesium sulfide then after would float on molten iron as the molten slag. You could skim off this molten slag. So is the way we manufacture high grade steel there. Then students, it's the rest of the magnesium. It's very small, the quantity, but perhaps those are the well-known applications of magnesium. Are used in distress flares, fireworks, as well as in concentrary devices. Those tiny particles of magnesium there are used as they could easily ignite. Okay, then students, further those magnesium could be used in medicines as well, manufacturing antacid tablets and such. Okay, those are the applications of magnesium. So then let's find it out, the amount of magnesium manufactured all over the world. Okay students, when you check for the total production of magnesium all over the world, you could find it out in year 2016, the total production of magnesium being 910 thousands of metric tons. 910 thousands of metric tons. It was China. They are the leading country participated or contributed manufacturing magnesium there. So China's contribution could be found out as 800,000 metric tons. When it comes to the present situation, China contributes 90% to the total production of magnesium. But when you go back to year 1993 or before that, you would find China's contribution just being 5% around. It is not that significant. So what happened is, it was with the rapid development of China's economy, China required some magnesium alloys in their productions. So they started manufacturing more and more magnesium alloys. They had more ores, magnesium ores, as well as energy sources. These students, with that China's production, some other countries could not compete, and it was not that economical, their productions of magnesium. So then some magnesium extraction plants had to stop there, being unable to compete with this increasing production of magnesium. It's currently Western Europe, they do not manufacture magnesium. Some other few countries that extract or manufacture magnesium are United States, Russia, Israel, as well as Kazakhstan. Okay students, it's finally we have come to the extraction process of magnesium. Though I call it process, actually it's processes. There are two major processes being employed all over the world to extract magnesium. What are those two processes? First one is the thermal reduction. Thermal reduction of magnesium oxide. Is we are going to reduce magnesium oxide into magnesium. There. So the second one is the electrolytic process. Electrolysis of molten magnesium chloride into magnesium. So this process is called Pigeon process. Pigeon process. This process is called Dow process. Dow process. So students, actually what we have in our syllabus is nothing else but this Dow process. So the reason that we talk about the Pigeon process is what they use in China to extract magnesium. So what's the importance? Students, China contributes 90% for the extraction of magnesium. Therefore, we could call this process as the major process currently they use to extract magnesium. Therefore, I'm going to brief you some important information regarding this process called Pigeon process. So, if we are going to find it out, this process in more details is what we are having, Dow process. Students, then this process, Pigeon process, is actually after the Canadian scientist named Lloyd Pigeon. He invented this process, was named as Pigeon process. So let's find out some information regarding Pigeon process. In Pigeon process, they use either magnesite, is magnesium carbonate, or dolomite, is a mixture of magnesium carbonate and calcium carbonate. They use as the raw material. So it's you would find they decompose. Let's use dolomite. It is magnesium carbonate, not calcium carbonate. So this is dolomite. So they decompose this dolomite in a kiln as to get their oxide. It's magnesium oxide and calcium oxide in a mixture. You get there. So students, it's additionally you get carbon dioxide as well. This is a reversible process. Therefore, it's you need to remove formed carbon dioxide, facilitating that. So otherwise, it could follow the backward direction as well. Therefore, you need to facilitate the removal of carbon dioxide to make that your forward direction is more favored. Then students, it's the formed magnesium oxide calcium oxide mixture thereafter is subjected to reduction. It is reduced using the reducing agent. What is the reducing agent that we have here during this process that we employ? It's what we call ferrosilicon. Students, it's an alloy of iron and silicon. It consists of 80% of silicon. There in ferrosilicon. How would you manufacture ferrosilicon? It's silica, sand with coke, carbon, and it's scrap iron. You mix them together and heat. Then you would get ferrosilicon. In ferrosilicon, you would find 80% of silicon. Then students, you need to powder that ferrosilicon and mix it with this mixture, solid mixture of after decomposition of dolomite. Then you need to heat. You need to provide a huge amount of heat, as it is 1500 to 1800 Kelvin. But it is you could use alumina as well. So using alumina, you could reduce the melting point of the mixture. Anyway, mixing alumina here with this mixture, you could ferrosilicon and decomposed dolomite, mixing that with alumina, you could heat it up to within this range, up to 1500 to 1800 Kelvin. Then students, it would form magnesium and its gaseous state, as well as silicon dioxide, solid. Then magnesium boiling point is around 1091 degrees of centigrade. So at this high temperature, it would be formed as its vapor. So then you would remove this vapor providing very low pressure, means this reaction is done under very low pressure. Then you could remove this vapor and condense that. So when you condense that, you could get magnesium liquid. Then you could solidify that into magnesium ingots. So you would get 99.99 pure magnesium there by that process. That's what we call the fission process. So students, finally this silicon dioxide formed would react with remaining calcium oxide, forming the slag, calcium silicate. You would get molten slag there being formed. So these are the reactions they are involved during the fission process. Okay, these are short informations regarding fission process. Then students, let's find it out. Our most important in our syllabus, it's the most important topic, is the Dow process. Okay, so the Dow process would be followed as 4-step process. So what are the 4 steps in Dow process that you have learned? So anyway, I need to tell you this. In our Earth crust, we have 8 most abundant element. Being what? It's magnesium. Magnesium is the 8th most abundant element. They are in Earth crust. So if you could find out magnesium in forms of magnesite, magnesium carbonate, it is dolomite, a mixture of magnesium and calcium carbonate. It's mostly in seawater you could find. So it's economically more favorable extracting magnesium from seawater. If you use straightly seawater, you need to evaporate water from seawater. It's what we call reverse osmosis. Or otherwise, you could use the waste solution after extraction of NaCl, salt in solvents. The waste solution is called bitter solution or mother solution or mother liquor. Then you could use that bitter solution as to extract magnesium. Students, in seawater it is 1.3 kilograms per cubic meter, or let's say it is 0.13% by mass. It contains magnesium in it. So it is our major source here in extraction of magnesium when we follow this process called Dow process. Okay, then students, it's, as I have already told, it's a 4-step process. First step is the manufacturing of calcium oxide, if we are going to use that. So the second step is the formation of magnesium hydroxide. So third one is the separation of magnesium hydroxide as to form magnesium chloride. Last one is the electrolysis process. Okay, let's find them out, those 4 steps carried out during this process. Students, the first process is the formation of calcium oxide. You could use limestone straightly, or otherwise you could use dolomite. Anyway, you need to heat them. So we call this step as calcination or calcining. So when you heat them, they will form calcium oxide. Here calcium oxide and magnesium oxide. So it's a reversible process. So you need to make that sure forward direction is more favored. To do that, you need to remove formed carbon dioxide efficiently. So this is the process. In a kiln, you could decompose, you could burn either dolomite or calcium carbonate as to get their oxides. So the purpose is to form calcium oxide. This is the first step. Then students, it's formed calcium oxide. There you are going to use to dissolving that solution that you use as the source solution. It is either mother solution or bitter solution or the seawater after concentration, removal of water there, evaporation of water. So students, it's the second step. When you dissolve this inside the bitter solution, that bitter solution consists of magnesium 2 plus. Anyway, getting dissolved calcium oxide there, it first forms calcium hydroxide. It's a solid, slightly soluble in water. This calcium hydroxide formed would get dissolved in water, giving aqueous ions, calcium 2 plus and hydroxide ions. So students, you could find this OH minus, increase of OH minus concentration would exceed the ionic product, would exceed the KSP value, so would precipitate magnesium hydroxide. So then magnesium cation in the solution would go with OH minus there as to form the precipitate. Then with decrease of magnesium OH minus hydroxyl ions, this could provide hydroxyl ions continuously. So students, finally what you get is the magnesium hydroxide precipitate. Then if you use dolomite, you would have magnesium oxide as well, not being dissolved. It's not that soluble magnesium oxide. Then anyway, you need to add enough calcium hydroxide as to form magnesium hydroxide precipitate. That's the step 2 we follow there. Okay, then students, it's what we are having in step 3. Before talking about that, it's first you need to burn or decompose either limestone or dolomite as to get calcium oxide. Then students, that calcium oxide is dissolved there inside the bitter solution or the source solution, seawater, as to form magnesium hydroxide precipitate. So then you fill that magnesium hydroxide precipitate and you use concentrated hydrochloric acid as to form magnesium chloride. Magnesium chloride. So it's magnesium hydroxide with concentrated HCl gives magnesium chloride and water. So students, you would get aqueous magnesium chloride solution. Then you evaporate this aqueous magnesium chloride solution as to get magnesium chloride solid. It is first you would get hydrous magnesium chloride. So this solid, when you heat it further, you would be able to reduce the water content in it. So when you heat it more and more, you would be able to remove water more and more. It is in this way. This is hexahydrated, becomes tetrahydrated. Further heating of that becomes dihydrated. So you could remove, you could reduce water in it. So students, it's the last step now you have left behind. Then it's you need to heat the formed solid in a steel container as to melt that down. So it's I will give that in this way. This is actually an electrode. You have, it is carbon. So it's this you have got. This is what we use as to do the electrolysis process. This is where we do the electrolysis. These are the tubes that we provide fuel gas inside the furnace. Okay. So students, it's unique too. This is a steel. This is a steel container. Actually, it is the cathode. Steel, manufactured out of steel. Steel cathode. So it is steel cathode. Then students, it's you need to fill your magnesium chloride and you need to heat that. When you heat it hard, all the water would evaporate off, giving you first solid magnesium chloride, then further it would transform into liquid magnesium chloride. You need to heat this in between 700 to 800 degrees of centigrade to that high temperature. It is then molten magnesium chloride. Molten magnesium chloride. So students, next, this is your anode. It is the graphite anode, carbon anode. It is the positive end. This is the negative end of the electrolysis cell. So to provide fuel, it is you provide those fossil fuels, natural gas here, as to heat this that magnesium chloride in the container, steel container. That container itself is the steel cathode. Then students, it's you would be having anodic reaction. Anodic reaction there is you would have NiCl minus would get oxidized into Cl2, giving 2 electrons away. So this is the anodic reaction. You would get chlorine being liberated. You need to collect that chlorine out. That chlorine form could be used with water to form hydrochloric acid. So that hydrochloric acid again you could use there in the earlier step as to react with magnesium hydroxide solid to form magnesium chloride. Okay, then students, it's you could have the cathodic reaction. So the only cation here is magnesium 2 plus combines with 2 electrons, giving magnesium liquid. It is magnesium liquid gives. The reason magnesium's melting point is around 650, but the temperature here is maintained in between 700 to 800. Actually, it's about 740. 714 is the magnesium chloride's melting point. So then it is transformed into, this magnesium chloride is transformed into a liquid. Therefore, it's above even magnesium chloride's melting point. So then this formed magnesium here is formed as a liquid. Then it is less denser than what magnesium chloride liquid. When you check for magnesium chloride liquid's density, it is 1.68 grams per cubic centimeter round. But this magnesium liquid, its density is 1.584 grams per cubic centimeter round. Then students, it's those liquidized magnesium would be formed here. Those would be, then there would be some holes there on the steel cathode. Those could be taken off, separated here as liquid magnesium. Then you could solidify that into magnesium ingots. So is how we manufacture magnesium. Then students, it's during this process we are burning some fuel as to provide heat required. Therefore, its formation of carbon dioxide, not even here in the decomposition of dolomite as well as limestone, formation of carbon dioxide then is environmentally not that favorable. It's environmentally not that good, not healthy. So it's a disadvantage that liberation of carbon dioxide during this process. Anyway, this is the process that we use to manufacture or extract magnesium. So there we use a steel anode, a steel cathode. It is graphite anode. Then it's around 700 to 800 degrees of centigrade, the temperature there, as to keep that melt as well as keep the form magnesium also at its liquid form. It is we collect liquid magnesium out there. Then students, those are the informations that you need to know regarding magnesium extraction Dow process. Hope you have understand these few simple things, simple facts. So students, we are going to finish it, this magnesium extraction Dow process or magnesium extraction process here in this video. So we are going to meet you in another chemical industry video in our future videos. Okay, with the hope again to meet you there in our new video, we are going to round up here. Hope you have understood these things. If you find any difficult point, any matter regarding this, you could mention there in the that box regarding comments. So you could comment on our videos there. Okay students, we are going to round up here. Goodbye.